Hi, I'm Lewis Castle, the co-founder of Westwood Studios, the executive producer, art director, and technical director for Blade Runner the game. To get to the same emotional response of the movie, we had to invent all new technologies and treat this medium differently than anybody had done before. For Blade Runner the game, we decided we had to create an emotional experience and a story that would give you a feeling of being a detective. And to do that, we had to move to something that was a little different than the shoot-'em-up first-person shooter games that were out at the time, or even story games that were out, which were kind of, if you go the wrong way, you die, kind of adventure games. Games like Monkey Island, games like King's Quest were the adventure games at the time, and the shoot-'em-ups were really kind of Quake, or actually I don't think Quake was out yet. It was really Doom and some of these other maze-like shooters. Blade Runner was designed in 1995, and at that time we had two-dimensional adventure games which you could click on, and you had some running guns that were done like kind of blocky-looking mazes. There really wasn't any kind of open-world adventure games around. This was the very first one. Westwood came very late to the process for bidding for Blade Runner. When we came in, it was pretty much decided, we found out later, that they were going to go with another publisher. But we came in and we showed that we really appreciated and understood what the emotional response of the film was, and we had a very good idea about how we could create an interactive experience that would be truly authentic to the film. I think at the end of the day, that combination of understanding the film and having a technical demonstration that we could actually deliver on that understanding really sealed the deal for us, and that's how we got the deal. When we pitched Blade Runner the game, it was to the Ladd Company, and Bud Yorkin in particular. They were the people who actually paid for the completion of the movie. They didn't get on too well with Ridley, so we really never had any interaction with Ridley Scott. But we were big fans of Ridley's movies, and I understand from interviews and things later that he was pretty happy with what we had actually done. I think the reason that we really got the contract for Blade Runner was that we demonstrated that we could recreate the visual authenticity of the film and the audio experience that was just really amazing at the time for the film. And we could do so in a way that was interactive and something that was going to be new to the space. So that kind of taking some risks creatively and the ability to really understand the original IP, I think that's what did it for us. At the time we made Blade Runner in 1995, graphic cards were very early in the industry, so there wasn't a way to put a lot of polygons on the screen. And so to get to anything close to the kind of visual quality you would have from the film, you had to be doing something that would be almost like standalone or point-and-click adventure games. So when we set out to build the Blade Runner universe, the first thing we did was we went through a very detailed process of understanding how the sets were built for the film. And it wasn't until we brought in the set designers that actually had to take Sid Mead's concepts. We did hire Sid Mead, who was the concept artist for the film, but they were the ones who actually imagined how that would be built into an actual physical set where people could walk around in them. So it wasn't until we recreated that exact process in 3D and rendered it as 3D images before we could get a look that felt like the film. And honestly, until we animated that and had actually the rain coming in and the fog and all the atmospherics, it just didn't feel like the film at all until we did all of those things. So effectively, what we had to do with the game was make a living movie. And that's where we started from, which is here's these cutscenes that look very close to the film. How are we going to turn those cutscenes into interactive experiences? When we were building Blade Runner and all the games in the 90s, we were actually one of the first people to use a rendering farm. We had consumer-grade Pentium 90s, and we had them all stacked up on Gorilla racks. And I actually wrote some batch processing software that helped us put all the images together. So we would literally have to render each one of these frames. It could take 20, 30, 40 minutes per frame to render on these P90s, and we have to reassemble them back as movies again and then compress them. And that actually ended up being the core technology that allowed Blade Runner to become a game, which was this idea that we knew how to create these visual spaces, these 3D spaces, on very low NPCs at the time. You're talking about 80, 86 processors, so a few megahertz. They weren't even in gigahertz lands there. So the idea that you could make a scene that had a few 100,000 polygons, that's about the most you could ever do, and that was only if you could pre-render it. You couldn't do anything like that in real time. So when we went to Bud Yorkin, the Blade Runner partnership, and presented the idea for the game, what we had done is recreate the beginning sequence of the movie where the spinner flies in over Watts and the fires are flying in the air and everything. We had created that, and we had another scene where a character would talk to a character and have an interaction. Once we showed that to them, they said, well, it sounds just like the movie and it looks just like the movie. What would you use from the movie if you can recreate it in 3D? We said, well, we wouldn't. We wouldn't actually use any of the film stock or any of the audio. We would recreate everything from scratch. And that way we could have a consistent look throughout the entire game. And also because we had to create a lot more places that existed in the film. In the film, there were only a few sets that they used many times. We had to create an entire world. So it was necessary for us to recreate Blade Runner, and that was the pitch that we gave to them. Yeah, you have to understand in 1995, there were no game engines to use, so everything was written from scratch. So for Blade Runner, we didn't have any conception of like, oh, Unreal could do this or Unity could that. It was basically, well, here's what we want to do creatively. How are we going to solve that? So we got the freedom, or had the freedom, to basically invent everything we needed to do to deliver that artistic vision for the game. Our initial pitch for Blade Runner was very ambitious, to say the least. But we had already done some rendering, so we knew we could get to the visual quality. And we had done a lot of work in compression. So I knew as a creative director and a technical director that we could deliver on the animated single screens with some Z buffering and everything else. What we really didn't know is how far could we push that technology? What else could we do with it? And we certainly hadn't invented our voxels yet. We didn't know how we were going to do the characters exactly because clearly they needed to be able to move around in three-dimensional space and turn and things like that. And sprites just wasn't going to do it. There would be too many and it would overwhelm the computers of the day. So we had some technologies we knew, and we had a lot of them that we didn't, but we had a pretty good notion of how we'd do it. And over the next few months, as we were negotiating the deal, of course, the movie had been out much earlier, so we weren't under a lot of time pressure to do a deal. So over the next few months, as we were trying to negotiate all the terms of the deal, we went through and specified exactly what that product would be and how we would accomplish those goals, and even had a chance to prototype some of the technology. So by the time we put ink to paper, we were very confident in the game we were going to make. And in fact, Donnie Blank, and the team had put together this great big binder of exactly how the game would be put together. So when we originally pitched Blade Runner, we recreated the movie very, very faithfully. It looked very close to the original film. It sounded just like the film. And so essentially what we had done is we had set the expectation in our licensing partner that we were going to be able to recreate the film. Now, remember, we had like these little computers that couldn't do the kinds of things they could do now, and we're talking about a total budget of a couple $1 million, right, versus a film that cost many, many times that. So it was pretty audacious to say that we could recreate those elements. And then, in fact, we had to actually recreate the film and a lot more. Because in a game, you have to be able to go in all these different places. You don't just walk around on the outside. We have all these other shots that we have to have many, many times, hundreds of times bigger than a movie. So it's pretty audacious to believe that we could do all of these things. But Westwood was pretty plucky back then. We didn't shirk away from hard problems. So we took on a bunch of things, a bit like the dog chasing the car and finally catches the back bumper, right? So we got the license and we were ready to go. So we chased after that big goal. Once we understood that we were going to recreate the visual quality of the film in an animated environment with characters that could move around, that had their own agency, it was pretty clear we had to have some new technologies. Video compression and video playback wasn't enough. We had to have a sense of depth in the world, so we had to create a type of buffering that would run in real time. We had to create lighting, so we had to create deferred rendering and normal vectors that would actually allow us to light the scene. We had to create real-time compositing that would allow the Z buffers to work together, and we had to do all of those things inside of loops that would be repeated but also lay on top of each other so you didn't get the sense that the world kept repeating itself over and over again. That's okay for a neon sign that blinks, but it's not so good for a car that drives by. You don't want to see the same car go back and forth. We couldn't do characters with polygons because the tech wasn't good enough at that time, the hardware tech. So we had to invent a way to do the tech for characters. We used voxels for that and had to invent that. But even voxels weren't really sufficient. We had to do something which it's kind of a voxel light. It's a sort of spindle-like things. We call them slice models. So we had to invent all of these different technologies, and even that wasn't quite enough of a challenge because to make the game feel like the movie, we had to make a detective game, which meant that you couldn't be able to get a guidebook and just walk through the game. That wouldn't be much of it being a detective. So we had to create a simulation that would create a story that was compelling, that sort of met the bar of Blade Runner, but it was also unpredictable. And that was the whole crux of Blade Runner, was this idea of what is real and what is not real, what's human, what's not human. So being able to make those things fuzzy and make it harder for people to understand, is my character a real character? Or are they a Blade Runner? Is Blade Runner a replicant? I don't know. That was also part of the problem. So it was a creative problem. It was a technical problem, many technical problems. And overall, it was just a bundle of things that were very different than anybody had ever done. The building of Blade Runner really started with the idea of how do we create the immersive environment? That was the art technical problem. And from a game design point of view, it was how are we going to create the feeling of agency in the player? Make the player be able to decide for themselves, am I a replicant, am I a human? And so the way we did that was we broke it down and said, okay, well, every time you play the game, you're going to have the same set of characters in the game, but we're going to randomize some of those characters. Sometimes they're replicants and sometimes they're humans. And because of that, they would leave different kinds of clues. And because the clues were different every time, you had to actually go get the clues to try to figure out whether or not the person was a replicant or not, because shooting a human was illegal and would end the game. Actually, it didn't end the game. That's another story. But it made the game much more challenging because now you were a murderer versus somebody who just retired, aired out a skin job, as they said. So that made it really hard because from a testing point of view, from a game design point of view, we were never really on solid ground. We could never be sure that any given scene would play out the same way because the game kept track of the player and whether they played as a replicant or they played as a human, and the world would react to them based on the things they've done. So the world would behave differently if you went around shooting everything than it would if you went around trying to be very cautious. At the same time, you never really knew if the person you're talking to in the game was a human or a replicant, and their responses would be subtly different depending on which ones they were. So that all that sense of unease and uncertainty helped to create that sense from the original film where you just never knew that tension of any time, any moment, this slow-moving, methodical pace would suddenly explode in violence. And that's exactly what we created with the game. You go through each scene, clicking around, and you start to get comfortable, and all of a sudden somebody comes in and starts shooting at you or comes chasing through the scene, and that sudden explosion of violence, of action, made you tense and nervous at all times, even when the scene was quite sedate. Well, back in the 90s, every game that was being done was built on homegrown tech. There was no engine that everybody used. I mean, in fact, companies like Sierra Online had a graphics engine for, they would do their things, LucasArts too, but those were really just the shells. Anything that you want to do that was innovative, you had to roll your own. For Blade Runner, we probably bit off an awful lot. We wanted to invent new ways of doing graphics, new ways of doing gameplay, new ways of doing just about everything. And in fact, a lot of the stuff that we worked on for CD-ROM stuff from Command & Conquer ended up helping us with Blade Runner because there's so many problems with the CD-ROM as a medium, and all that learning really helped to inform us. But that was all internal tech. None of that was middleware. That just didn't exist. So one of the things people always ask me is like, what compression technology did you use? You must have used like Bink or something like that. And I'm like, no, we couldn't use that. And the reason was not that Bink wasn't great, but Bink was made for video. And it was very good at just doing video. But when you look at the data throughput rates and the speed at which you could render it on the screen, it wasn't close to the kinds of things we do. Because we had to basically be running anywhere from 6 or 7 streams continuously and simultaneously on the screen. So we had to be much, much better than the best-in-class video codecs and compression algorithms you could buy at the time. So we were really way ahead of the curve in so many ways. And it goes all the way back to in the 80s when we used to do fast-loading cartridge technology. And we had to learn how to do compression and serialization and how to make those things very, very small and very fast and very accurate. So all of that learning over the many years built up to this point where we could do something where we could have many, many times the amount of data on the screen than other people thought was even possible. So the teams at that time, a big team was about 10 or 15 people, and I think we had about 20 people on Blade Runner. So it was a fairly large team. And part of the problem was deciding who's going to do what and how we're going to get all this stuff done. There's a lot of work. So we created a very regimented process of concept art that would go through many revisions and approvals that then would lead to models. And for every model in the game, we had to hire a voice actor. We had to have a physical actor to put on a spindle and scan their bodies. And then we had to have an animator who would rig it and do all the 3D stuff you do now. So every single person, every single character in the game was actually 3 or 4 people. All of these things broke down. We had our own studio at Westwood, which was great, so we could do all of our own filming. And we had our own motion capture. And we did thousands of sequences of motion capture. Every movement of every character in the game was a motion capture sequence. Our system captured at 120 hertz, and we had to reduce that down to about 20 hertz by grabbing keyframes and then build the individual models to make those animate. So the amount of work to just make all the characters move around the world was an enormous amount. It was really important to be organized and to constantly re-examine how much time it was taking to do everything. I think we were probably, it was supposed to be a 1.5 year development cycle. We went over by 6 months. I think we were about a year into it when we realized that there's just too much here. We're trying to do too much. How are we going to get it done? And so we had to start making some automated processes for processing the characters and some shortcuts for getting things into the game. Ultimately, that's what led to a lot of the characters looking very blocky in the backgrounds. We had to make some choices. Every character in the game could technically look beautiful and perfect, but the amount of manpower to make them do that was just outside the scope of what we could do in the time we had. So that's where we cut corners. We just, at the end of the day, had to do that. One of the technologies we had in Blade Runner was the ability to actually move the camera through these beautiful environments. That didn't come around until very late in the process. So we put back into the game, and all these sequences where a character would go around the corner and we would just cut to the next camera, we would put in a camera track that would do that. And so we layered those back in at the end. And honestly, if we had known in the beginning we could have done that, we would have made that a key part of the game. But instead, it kind of looks like almost like a trick, because we just didn't have the opportunity to have that technology early enough to embed it in the entire product. So as a creator, I don't think any game is ever done. You always want to do more, or you always have something you would have done differently, or something you would have done if you had more time and money. But ultimately, I think in the particular case of Blade Runner, the one thing I wish we had a little bit more time was with those characters, because it did degrade the quality of the game experience to have these kind of very blocky characters in the background. But other than that, the original script, the original shooting script that we had, and I don't remember how many, it's a book about that thick. Thousands and thousands of pages altogether when you add all the interactive sequences in. That original script got entirely put into the game. All of our characters made it in. All of our ideas made it in. The places where we had to cut back a bit was just the quality of the characters in the background, and some of the places where we just didn't get to go deep enough in the number of options you could have in a particular environment. But overall, I was very proud of where Blade Runner landed. It felt like a complete game when we shipped it. As a game maker, I knew all the things we wanted to put in that we didn't make, but the people who are playing it don't ever know that. We had 47 different varieties of endings. There's about 6 or 7 major ones, and then like 4 sequences that were really detailed with big animations and everything else, and then variants depending on which kind of characters were in there. So the dialogue changed based on how you ended the game and who was a replicant and who was a human. There were lots of Easter eggs that we got a chance to put into, which is one of the things you always like to do in a game. One of my favorites was you could play the game as a Rambo character, which we called it Rambo and Gandhi. You could play the game just running around shooting gun, or you could play the game very passive and try to save everybody. Well, one of the things you could do with Blade Runner, because it was a living simulation, you could play the entire game saving all the replicants, get to the very last scene, get on the shuttle, get ready to take off to save them and bring them to off-world colonies, pull out your guns and shoot them all. And then you got a very special ending for that, where you walked out of the shuttle and your cohort, Crystal Steele, walks up and says, "I didn't know you had it in you, Slick." And it was really fun, because up until that point, everybody's chasing you. Everybody thinks you're this replicant sympathizer, but in the end, you decided that you were just tricking the replicants and you shot them all like cattle. So that kind of attention to detail and those kinds of things made it a really special game. So one of the most audacious things we did with Blade Runner was early on we said our editing environment for the game, our game editor, is 3D Studio Max. Everything was built inside of 3D Studio Max. We scripted inside of 3D Studio Max all of the things that the characters would do. And the environments, the 3D Studio Max environments, were the ones that the programmers wrote to create the collision spaces and to create all the interactive spaces. What that did was it allowed our artists to go back and change things anytime they wanted, and everything would automatically change with the artists and sometimes break things. But at the end of the day, everything lived as these really, really high polygon models. It looked a lot like it does now, where we create these incredibly rich environments and we're interacting with them, but of course we run them in real time. Back then, we couldn't ever render that stuff in real time. So the first problem we had was we had these beautiful scenes that were really wonderful, and when they animated, looked great, but we had to compress them down to a really small space. At the time, games shipped on CDs, 700 megabytes to a CD, and Blade Runner went out on 4 CDs. So that's how much space it was. And that's compressing the game down to where loops of video would run through single-speed CD-ROMs at 44 kilohertz. I don't even know the thousands of hours that we had. It was really huge. So the idea was start with compression. So we started with the compression. We said, look, we can make these beautiful scenes that are really lush and really detailed with all this lighting, and they look wonderful. And we've crunched them down to where we can fit, and they look great. Then it's like, well, let's animate them. Okay, and once you animate them, of course, now you end up with several seconds of animation. You have to be better at the compression. So we had to take our compression technology, which was really around these codecs, around blocks, basically Limpel-Zev-Welch compression-like thing, a tokenized compression. And we had to actually make it more of a trilinear compression that would look through time so that we could make use of the fact that blocks were repeated over time. And this was pretty innovative when you're talking about 8 or 9 seconds of video. At the time, even things like MPEG would only do a couple of frames, not dozens or hundreds of frames, but even just a couple of frames. So we had look ahead that was all the way out several hundred frames later. And that was the only way we could compress all that data down into a small code book that we could play back at real time. But even that wasn't good enough, because at the end of the day, where our tokens size got too big. So we had to do some predictive stuff. So we added on top of that predictive elements that would say, well, when looking ahead through this one particular block, it looks like this block changes in this way. Let me see if I have a mathematical algorithm that can actually build that and use math to generate or predict what it was. So in much the same way that you would do like now, if you're a really technical person, you would do like rewind sync on server code. Same kind of thing where we kept using prediction to create a smaller delta so we could have a better compression. And once we were done with all that, we had this beautiful environment that looked amazing. And it's like, okay, this looks like the 3D rendered stuff. It was better than the stuff we had done for Command & Conquer to the date, and it was really great. Now we're going to put a character in it. You have to go back in time. Everything that was put on a screen back in the 90s was put as a raster. So you literally had a piece of code that would poke a value into a place in memory, and that would create a pixel. Everything was rasterized. So we had these things called sprites, where basically just a bitmap that you would stamp into the environment, and they would have like an alpha mask, basically. There were no Z buffers. Like, we had to create Z buffers. There was no hardware that did that. That was something you had to actually maintain in software. And so a sprite was just basically a two-dimensional map of a character that you would stamp into the world, and you would either have a Z buffer or you would do them in order to make sure that they would look right. And so the idea was, let's go put some sprites in there. Well, they looked terrible, right? Like, but the idea originally was, we'll just use sprites and, kind of we'll move them around and keen them and everything else like we did with our other adventure games. It clearly wasn't going to work. Because the minute you put a sprite in that environment, even though we had the 3D, the Z buffer, it just didn't look right. That was something I didn't even mention. We had to compress the Z buffer as well, because the Z buffer was what allowed us to composite in real-time things like characters moving around the world. So then we said, okay, well, now we have the sprites. They don't work. What are we going to do instead? Before we had even signed the deal, we started working with this idea of voxels. A voxel is a single graphical element that is a volume instead of a single pixel. And because it's a volume, it can be wrapped around. Let's think of Minecraft. If you took Minecraft and shrunk it down, that would be voxels. Everything's made of little blocks. So they looked great. The voxels looked good because pixel by pixel, they looked very much like the scene. And the kind of blockiness you get from voxels when you go to render them back then, pixel by pixel, they're really kind of voxel unit by voxel unit. They look very blocky too. So they matched the kind of compression of the scene, so they felt really good. What was also nice about voxels is we, at any given time, because we put them on a spindle and we did slices of them, as we were going around the outside of the character, at any given time, we had the normal vector of what that particular pixel was. And so we were able to actually add another layer of compression. So we didn't just have the scene, we also had the Z buffer. Then on top of that, we added another layer, which was a lighting buffer, sort of like a deferred renderer, that would have lighting information so that the character, as we're rendering the voxels, we could actually allow light to land on the character. And that kind of solved the deal. At that point, when the character like McCoy walks into the scene and picks up all the light from the neon, and if there's a big spotlight that's hitting the water and it's splashing up and with all this global illumination, because that light information was inside 3D Studio Max, the character that walked on the scene would pick up that light, and it looked very believable. And technically, it wasn't very accurate, right? I mean, it was really sloppy. But because the characters were sort of blocky and things were just kind of, there was really not very, very precise, we got away with it. And so we thought, okay, that's really great. We're done. This is going to be amazing. As we started to build the game, we started to do all the sequences, we realized that there was another thing that was missing. Blade Runner has all this atmosphere in it. It has all these clouds and steam. And so the problem with Z buffers is they're Z buffers. They're opaque, right? So the character would be walking into the distance and they wouldn't be affected by the steam. They would just be stamped out over the top of the steam. So if they walked through the cloud in the distance, they would look wrong. So then we had to add on top of all of that another system that managed volumetrics. And so we put imposters, basically probes, inside the environment that were invisible when we rendered them. But that information in real time was used to add effects onto the voxel characters to make them appear to be going into the steam, to gray them out if they were into steam, or make them go a little darker if they went into areas that were really heavy shadows. And once we did all of that, we actually even had shadows that could fall across the surface of an object. We got to the point where the characters looked so believable that they could do just about anything. And so we were finally there. And then I still remember the day we were probably, again, 2/3 of the way through development. And we said, well, all of this stuff works. There's no reason that second and a half of cycled animation couldn't be a second and a half of a camera that tracks around a corner. And because everything was in 3D and everything had three-dimensional placement, You could have characters walking around in the background inside a hallway, and the camera would fly down the hallway, and everybody tracked perfectly inside the space, including all the lighting and everything else. In fact, if a spinner flew by and flew down the streets, the walls would get wash of the color and the light from the spinner. And all of this was just a bunch of simple tricks. I mean, it was all about this compositing of these elements together. And at the end, it was very convincing. So I remember doing reviews at the time. People said, how many polygons in this scene? I go, millions. There's millions of polygons because that's what the original scene was. They go, but there's not even a million pixels on the screen. I'm like, well, no, but there's millions of polygons in there, and all of it's being treated in a very, very sneaky and compressed way, but that's what those scenes look like. And so to this day, if you take Blade Runner and you look at the video from the film, or from the game, and you look at the film, they're very, very close. In fact, the game, if you look at anything else from 1995, it's not even close. It's a night and day. Nobody even came anywhere near what Blade Runner did. Blade Runner was a great fun, and I think we all really enjoyed it, but there were definitely some frustrating times, and I know I frustrated my team. I just wouldn't compromise on the visual quality being absolutely as high as it could possibly be. And there were a couple suggestions that we should probably just go with a much simpler system for characters. There were a lot of ideas like, hey, we don't need to motion capture this stuff. We could just do some simple animations or whatever, transforms. At the end of the day, I wouldn't have it. It's like, no, we need to do everything we can. I love this movie. It's my favorite movie. I want it to be as authentic as possible. And because I have a fine arts background and a technical background, I was just uncompromising on the visual quality. It just had to be the best. So I think that's probably where we probably pushed the hardest, was just we had to invent new things because the way that you had to do things back then for graphics just couldn't get to the quality that was anywhere close to film. When I started Blade Runner and we pitched it, I remember coming back and Brett had asked me, he said, hey, how'd the pitch go? And I said, I think it went really well. Hard to tell. These guys have good poker faces, right? He goes, so are you excited? And you know it's your favorite movie. His favorite book was Dune, so we had just done Dune, and we were both on top of the world. Done D&D. I love D&D. And I said, the one thing I'm terrified of is the Blade Runner fans coming after me and wanting to kill me for doing something terrible with this property. And I think that motivated me more than anything. As a fan of the property of the movie, the thing I was most afraid of is, what are the fans going to think? I would just be mortified if I had done something that they felt was a travesty for the IP and had done something that belittled it or took away from the value. And so that motivated me more than anything. I feel like we were successful. My takeaway was nobody sent me hate mail. I didn't see any, mean, trollish things online. Generally, people either loved the game or dismissed it as maybe, it was kind of simple. It wasn't quite as deep as I wanted or whatever. There's always that not big enough, not deep enough argument. But generally speaking, it was well received. And the fans were really appreciative of how hard we worked to be authentic to the IP. And so my takeaway was good work to the team, the Mikes and David Leary and all those folks that worked so hard. They really, we all could have done a few more things differently, but at the end, the fans liked it. And I think that was the validation. People ask me all the time, is there any point where you just thought, okay, we're hosed, we're not going to make it? I don't think so. I think my optimism runs eternal. And to this day, I'm probably still way too optimistic about things. There was no point where I didn't think we'd get there. There was definitely a point in time during Blade Runner where we felt, okay, we're going to need more time, we're going to need more money. And the amount of money participation we had from our partnership, the Blade Runner partnership, was capped. It was part of our deal. So we did have to go back to our owner, publishing partner, and say, hey, we want to spend a few $100,000 more on this game. It's an adventure game, which nobody thought could sell. And because it's important and it needs to be done for the quality. So that was on me. And in fact, some of the other things, it's like getting things funded back then, it's like now, really hard. So that was probably the only time where I had a really crisis, was like, oh my God, where am I going to get this money? I can't write the kind of check that I need to write. I got to get the money from our owner. And are they going to buy into this? Are they going to believe this crazy idea that we're going to sell an adventure game that's going to sell more copies than any other adventure game could just to break even? So that was probably the only time where it was really not that we wouldn't get the game done, that we couldn't get the game we wanted to get done. We needed more time. We needed more money. The biggest thing that pressed us to finish was we had gone to a trade show. We had so much excitement behind it. Virgin had this incredible amount of energy behind the game and the people wanting to pre-order it. And it was really a calendar date that made us have to make decisions. I think by then, after that show especially, the world knew and our owners knew we had something special. It felt a lot like Command & Conquer, Lion King, a couple other Lands of Lore, a couple other big games Westwood had, where you kind of know at some point you've got something big. You don't know how big, but you know it's pretty big. And I think we could have gotten more time and money, but we couldn't take the time and money because we had to get the game out while the energy was there, while people were excited, and the world was changing quickly. And so I think at the end, it was less about, it was certainly hard to get the time and money in the beginning, but once we delivered, it was more about, we got to get this thing done because now is the time. And if we wait too long, we have to start all over again. We'd have to go redo all the assets. We'd have to, everything has to get better. And so you find yourself in game development quite often. Even today, this is still true. You're getting close to getting the product. It's almost there, and you realize now, wow, if we had done something differently or with a new technology or new techniques, we could do it so much better. And it's really a hard call. Do we take a little more time? Do we spend more money to up that quality? It's going to start everything over again, and next year, aren't we going to have that same problem? And so that's the rub. At the end, it's time. We have to ship it. What are we going to cut? What are we going to do to make it work? And again, the things we cut, nobody knew we cut them except us. so it worked out. And you never know how hard that's going to be. Sometimes you cut deep enough where the game doesn't get a good review or people are disappointed. In this case, I think we pulled it out. Because of the negotiations, it was a delicate time for Westwood. We didn't have ink on paper, so we couldn't throw the full dev team at it right away. So we had to just take the people we had and keep planning. I'll always look back and say that it's the closest game ever that I've made from the original design to what actually ended up in the hands of the consumers. That amount of planning was never wasted. I mean, it felt like we were wasting time. It was not a waste of time. And that's what I took away. And to this day, I might get criticized at times where I'm really insisting on a lot more documentation, a lot more planning. But from my experience, thinking through those things as much as possible was a learning that is just, you can't replicate that. Once you realize that that's what you have to do, you obsess about planning. And since then, I would say the best thing is to actually put it in the hands of customers. We just didn't have that option back then. Well, when we started off with Blade Runner, we started with that first scene. We got it compressed as a video. We played it, and we said, that's really cool. Then we added the Z buffer, and we could move things around. We could move like a big block, and it could move through the world and pass through things like, ooh, that's really cool. This is going to work, And then I think the kind of sad trombone sound was when we put that sprite in, and we're like, ooh, that doesn't look good at all. And we knew we had to come up with a new technology. Unfortunately, we were still in that early stages where we hadn't committed to anything. So we were like, okay, maybe this isn't going to work. Let's try something different. That's when we did the voxel stuff. It was an evolution. So in the very beginning, we were pretty sure all we would do is have about a second or so of video that would loop. So rain, but maybe a sign that blinked rather fast, a couple seconds at most. But we couldn't do anything that was any really much longer. And every time we came up with a new idea on how we would do new technology, of course, it added more onto the total load of what we had to process and get on the screen. And every time we did that, we had to find better compression. And I remember as a compression geek, and that's what I love doing, saying in the beginning, it's like, well, 47% of the original size, that's like kind of lossless compression, that's kind of data entropy. If you're going to go lossy, you can get to 20% of the original size, you're pretty much as far as you can go. We were down to single digits. We were down to, when you did the effective compression rate of pixels, we were down well under 5%, 3%, 4% of the original image, which is a ridiculous amount of compression when you take all the data we had. And so that was the kind of thing that had to happen over time. It didn't happen right away. But every time we got those jumps in technology, we came up with a new idea. Oh, I know what we'll do. We'll do some predictive math, and we'll figure that out. That would give us some extra percentage, which let us put more in the game. And the team was really frustrated with me, too, because every time they got more, they go, okay, we've solved the problem. I go, awesome. Let's do it for 10 seconds. No, stop, please, uncle. So it was really fun in the sense that we kept finding ways to do more and get more fun stuff and make things better. And Bill Petro kept making the slice models faster, which let us do more technology for the lighting. And all these things just kept adding to making it better and better. I'm sure if we had another year, it would have looked much better and performed even better. But at some point, you got to ship it. At the time we were building Blade Runner, it was not actually possible on our lowest end platform to completely paint the screen with a pixel fast enough to be a playable experience. So if you think about how hard this problem is, you're going to have a bunch of stuff moving on the screen, pixels everywhere, rain, lights, all this stuff, characters moving around, spinners flying around, and you actually can't even scan the entire screen fast enough to keep a frame rate that's acceptable. So what we had to do is we had to manage dirty buffers all the time. And that meant that we had to keep track of what parts of the screen changed and what parts didn't change. And we had to be really economical about how we changed those pixels and what deltas we did. And we had to double buffer everything. So we would have one that was not being seen and one that was being seen, and we would be updating things on the other buffer. And some things we would do out of sync because they were such big pieces. We would actually have a third buffer where we would keep track of the future state of something. So we would know that in 8 frames, this is going to be the frame that's going to be drawn. So we'll create it over here, put the image in it, and then that way it would land on the screen. And that one would update at 8 frames per second while everything else was running at about 60 frames a second, actually about 30. 30 frames a second was about what we managed. So really, really hard problems. And people don't realize how hard these things were because today it's just like you throw things up there and you complain if the engine's not fast enough. That's not how it worked back then. Back then, every single pixel was your fault. So one of the things that's really important with Blade Runner was we had to imagine, at the time, really good selling, the best-selling adventure kind of games were 100,000 plus copies. We had to imagine that this game was going to sell 300,000 or more copies, which would make it the #1 selling adventure game. So the math for the business required the #1 hit. Well, to sell that many copies, you also have to sell to the lowest common denominator of machine. So 4.77 megahertz 8086 was the lowest platform we had to support. And at that time, those machines could literally not blank the screen fast enough to be able to do a compelling animation. And so all of the problems we had to support those low-end machines were absolutely required because otherwise we could never meet the sales goal of having so many copies sold. And there's a lot of companies that were very famous for making games that couldn't run on most people's hardware. We couldn't afford to do that, or we would never be able to earn out on the game, and we would lose a lot of money. So not only were the problems, technical problems, really big problems, they were also commercial problems because we had to support these low-end systems. The Voodoo 3D hardware out was very cool hardware for certain things, but as a practical matter, you would only be able to build a scene out of a few hundred, maybe 1,000 polygons because you had to have a decent frame rate and it could only render so many frames per second, and you had to have time for everything else in the game. You still had audio, you still had all the game logic and everything else. So even if the 3D card was fast, it's not a demo. Like you'd always see these great game demos. You're like, look at all these balls bouncing around. It's like, well, sure, but you have imposters, you have all these tricks to make it look awesome. But the reality was, under stress with a game, you were hundreds, maybe thousands of polygons, nowhere near the tens of thousands, hundreds of thousands, millions that we would need to do to create Blade Runner. So Blade Runner had another design challenge. As we were building this game, there were all these clues. So characters would pick up clues and hand them to other characters, and we managed to figure out the what we call the whisper or the rumor mill. So somebody would tell you that they saw a person who saw a person. Well, that piece of data was less reliable. So we actually tracked how reliable the information was, and characters would lie to you in the game based on whether or not they thought you were a friend or a foe. And that was really a cool concept, and it played out really well, but it became really confusing. So we exposed the clues database to the player through a thing called Kaya, which is the Knowledge Information Agent, and basically was an interface to the database, which was a clues database, so players could keep track of all the clues and keep track of what it is they're supposed to be doing, because otherwise you'd be completely overwhelmed. Well, as we were doing all that, we realized that it was really cool to be able to track that tracing of the things and be able to add that uncertainty of the clues so that I wouldn't just want to go talk to person A. I'd want to go talk to the person saw or go to the place where they saw it. That became a huge challenge as to how do you store all that data. And it turned out to be a really simple solution. We basically just, for every clue, we just kept track of the last person it came from. And we would backtrace the clue back to where it originally occurred, and then we would know how many times it had passed through different hands, and we could actually influence the clue based on the agents that were in the world. And a really simple solution made the game really rich and made it very deep. And it was a design problem that felt insurmountable. It turned out to be not hard at all. So one of the biggest problems we had with the database clues in Blade Runner was if you could rely on any piece of information, no matter who told it to you, to be perfectly accurate, it became unnecessary to go question people, because there was no reason to go to the place, there was no reason to do anything because everything was reliable. So we knew we had to create unreliability. And the problem was that the database was already huge by the standards at the time. It was taking up a huge amount of our footprint and memory. We just couldn't store many copies of the database. It wasn't possible. And so we had this insurmountable problem. We had to have unreliability of clues, but how do you do that? We can't just make it random. That's not going to encourage people to go look. And we had to have some way of learning about how things occur. And that's when we came up with the idea of tracking the clue from who passed it to each person by just simply remembering who the last person it was it came from. And that also allowed the characters in the world to have copies of the clues as well. So somebody would see you shoot a human being or shoot a replicant, they would know that you shot them. They would tell their friends the next time they ran into them. So they were running around in the virtual space of the world, and when they bumped into somebody, they would say, oh, I saw McCoy shoot a replicant, so he's obviously not a replicant sympathizer. And that kind of information would make the world react to your behavior. It also made it incredibly difficult to play test because, if you tried to replay the same scene again, you might have been standing just a little bit around the corner behind an occluding wall, and that character never saw you do the thing you did, and so they never handed the clue, or they didn't go in that direction, and it made it really hard. Playtesting was, sorry about that, guys. Glenn and those guys are still out there. If you're watching this, I'm sorry. sorry, 1,000 times sorry. That was an impossible game to test. So. It wasn't lost on the game development team, or myself and any of them. I think that the very things we were doing, the very criticisms we were having about replacing human actors with 3D actors, the idea that we couldn't really tell whether a person was a human or replicant, the idea that when you're playing the game, you're not really sure if you're supposed to be a human or you're supposed to be a replicant. It was open to all this. It makes you really start to challenge and question those things about what does it mean to be human. The very line from Blade Runner, more human than human, is actually accurate. If you think about the story of Blade Runner, the replicants are more humane. They're not just more human, they're more humane than the humans. That was what Philip K. Dick was playing with in his original short story. It's certainly what Ridley Scott brought into the film, and we had to capture that as part of the game, or it wouldn't have been authentic. And that was really a big part of what was exciting about making the game, and also kind of terrifying. I was like, did we get that right? I've had people actually come back to me and say, you got it right, so I think so. In making video games, we have this thing called the uncanny valley, which is if you make something that is iconographic or representative, it's really easy. A silhouette of a man and a woman is a man and a woman, binary, very easy to understand. A smiley face is somebody who's happy, a frown face. The minute you start to get more and more realistic, you get to some point where it looks kind of real, but it's not really real, and it's kind of uncanny. That's what they call the uncanny valley. That actually played as a huge advantage for Blade Runner. Because our characters were in the uncanny valley, they weren't really human, and they weren't really not human, and that was perfect.